Welcome everybody to the Celsius talk, Clean Code for Clean Cities, that has been kindly organized by Euroheat and Power, the DHC Plus technology platform, and Celsius. I hope you can all hear me well. I will be the moderator today. My name is Ines Arias, and I'm a project and policy officer at Euroheat and Power. Before we start, I would like to thank you personally for joining this webinar today. And before starting with the presentation, I would like to present you very briefly with what are the organizations that join efforts to organize this webinar today. Euroheat and Power, for those that are not familiar with the organization, is the International Association for District Heating and Cooling. EHP is a unique network of district energy organizations and professionals that connect industry players, decision makers, and academia in a joint effort to drive forward sustainable heating and cooling. The DHC Plus technology platform is set up under the umbrella of Euroheat and Power and is the European hub for research and innovation in district heating and cooling. And the Celsius platform, it's a platform of networking and knowledge that takes a holistic approach to overcome technical, social, and political barriers to district heating and cooling solutions. On November 21st, it will take place the Celsius Summit in Brussels to celebrate the official launch of Celsius 2.0, the continuation of this platform. You can find all the information to register on their website, celsius.eu. In today's short but hopefully useful webinar, we will be able to discuss with you and with the speakers how can we cool our citizens in a warming world while also keeping the cities cold, and what are the opportunities and also challenges that district cooling offers to cities of today and tomorrow. And to present their expert opinion today, we are happy to have with us two speakers. Susanna Padekopa from the Copenhagen Center of Energy Efficiency and Burkhard Holz from VIENNA. I apologize already for my pronunciation. As participants, you are able to participate in the discussion there in the presentation and at the Q&A session at the end by opening the commenting bar that you should have at the right side of your screen. Please feel free to write down your questions or perspectives there in the webinar. And after all, we are here to learn from each other. As a little bit of background, as you know, 2016 was the warmest year on record since modern record keeping that began in the 1880s, more than 100 years ago. And we have been experiencing record-breaking temperatures for the last 3 years in a row. This entails numerous consequences, as you know, for our civilization, and one of them is the increasing demand of cooling. In today's webinar, we will be focusing on space cooling, and more specifically, district cooling in cities. In this regard, demand is rising steeply in the EU, and the European Commission expects building cooling demand to rise 70% by 2030. Worldwide energy demand for space cooling will overtake space heating by 2060 and outstrip it by 60% at the end of the century, with a subsequent increase in CO2 emissions if this is not addressed efficiently. But the increasing demand in space cooling is not only based on calculations on the future. Final energy use for space cooling in residential and commercial buildings worldwide more than tripled between 1990 and 2016, and of course these figures will increase as consumer expectations of thermal comfort continue growing. In this regard, cities play a key role in fighting climate change. Energy demand and CO2 emissions are particularly high in urban areas, and at the same time urban density allows more alternatives for energy efficiency housing, eco-friendly transport and service provision, as it is the case of district cooling. Although cooling is still a new topic, or at least not a very recurrent topic in the energy policy debate in Europe, new initiatives have already started to increase awareness on the matter of cooling at a policy and research level. Two examples of these cool initiatives are Cooling EU and Cooling for All. Cooling EU, for those that don't know, it is a forum that brings together stakeholders representing the European cooling demand and supply sector to promote a more efficient and cleaner cooling supply, increase the number of dedicated research projects, and raise awareness on the importance of cooling. And Cooling for All is an initiative created under the UN Sustainable Energy for All organization, and it focuses on how we embed growing cooling demands that can reach everyone within a clean energy transition, and in turn supports faster progress to achieve the goals of the Montreal Protocol's Kigali Amendment that, as you know, it was agreed in 2016 in Rwanda. This is only a very general introduction to the topic of cooling, and now we will have our first presentation of the day that will focus on district cooling from a more research perspective. Our first speaker is Susanna Padekopa. She is a project associate at the Copenhagen Center for Energy Efficiency for the UN Environment District Energy Cities Initiative, and also she is a PhD fellow at the Department for Planning and Development at Aalborg University. Please, Susanna, the floor is yours.
Thank you. Thank you very much for having me as well. Hi, as Ines said, my name is Susanna Padekopa, and I'm here to talk to you a little bit about the work that we do in the Copenhagen Center on Energy Efficiency regarding district cooling, and very specifically our role in that is to support the District Energy in Cities initiative. So I'll talk you a little bit through what we do, why we do it, and then try to give you an example of the work that we've been doing in India recently, to talk about how we're working to bring this potential for energy efficiency further. So to start with, a little bit about the Copenhagen Center on Energy Efficiency. We are a research and advisory institution based around the hub for the SE for All initiative, so based around bringing sustainable energy for all. A lot of the work that we do is about aggregating projects and accelerating the development of energy efficiency projects. And we do that both by looking at policies and assisting policy change, but also through developing innovative delivery and financing models in order to bring projects on the ground. We have a wide variety of partners that we work with through these different types of energy efficiency projects. And we try through that to really be able to learn from the elements that come together within this center, specifically based on the idea of energy efficiency. So within the Copenhagen Center on Energy Efficiency, we have a small team that's working on district energy. As Ines explained, I'm both a PhD student and a project associate here, so I spend about 40% of my time here. Then we have Zulum, who works mostly on a lot of the cooling projects specifically. He's actually currently on a flight on his way to China. And we have Romanas, who works a lot more with the heating side and also the refurbishment and the restoration side of a lot of heating systems that exist still in parts of Europe and parts of Asia. So our role specifically is to provide technical background and technical support to the UN Environment District Energy in Cities initiative, which I'll talk a little bit about in a minute. But very specifically, we are there to help perform rapid assessments, which is both an overview of the policies that are in place, but also of the technical identification of high priority areas, and then moving into the design of the systems themselves. And working towards developing plans at a city level, but also at a national level for the development of and the uptake of district energy and district cooling in this case. So we do this by supporting the development of concrete projects as demonstration projects or as pilot projects or as ways to kickstart refurbishments in other places. We do this by analyzing the different experiences and the best practice engagements that we have with the stakeholders on the ground and with the partners on the ground in the different countries we engage in. And we try to do that by developing applicable methodologies and guidance materials for other countries to learn from and to work towards this aggregation and acceleration of the projects that we would like to achieve at the end of the project. So that's a little bit our role within the Copenhagen Center on Energy Efficiency towards district energy and district cooling in particular. When we look at the District Energy and Cities Initiative, then this is something which was launched in 2014 by Ban Ki-moon and is really aimed at developing not just district energy in terms of district heating and district cooling, but being able to nest that within energy efficiency as a whole. It's effectively done on the background of a flagship publication which came out in 2015, which looked at 45 cities around the world, which led the integration of renewables and the efficient production of energy. And one of the main common threads that came out of that was the application of district heating and district cooling. And based on that, the idea that district heating and district cooling can play a key part in bringing accessible energy and efficient clean energy to cities was put forward. And the support that has come out of that towards the District Energy and Cities Initiative, both then when we talk about 2014 and 2015, but also a few weeks ago at the P4G meeting here in Copenhagen, which exemplified district energy and cities as a good partnership between different multinationals, but also the private sector. So this is really an indication that what we've been doing with district heating and district cooling has been effective and taken form and has a big role to play in providing clean energy for all, and specifically in cities, and bringing energy efficiency to cities and urban areas. So the work that we do within the District Energy and Cities Initiative is global. We have 4 pilot countries in the form of Chile, India, China, and sorry, I don't think it's on here, Serbia. You can see the turrets, but you can't necessarily see the name of it. What we do in these 4 pilot countries is work both at a national level and then identify cities where we want to work with projects. And we do this through a methodology based on a rapid assessment, both on a technical level, but also on a policy level, and then a deep dive in the high priority areas and in the cities where the policies are applicable in order to move towards feasibility and move towards master planning in those cities. There's a big synergy between working at both the national level and at the city level, because it's both important that we work with the national governments in order to provide the frameworks and provide the political will and drive, but also being able to work with the cities very technically and close to the ground in order to help them develop the types of projects that will benefit them most and that can really serve in function of a long-term, clean, efficient strategy for heating or cooling, or both, whichever are applicable. So if we look specifically at cooling, then as I mentioned, India has really been the country where we've done a lot in terms of developing the pilot cities and being able to do a lot of rapid assessments. There are countries where we have both heating and cooling. Chile was initially envisioned as very much a heating country because that's one of the problems that they identified themselves as something that they wanted to solve. But as they've moved further into exploring the different ways in which district energy could move, cooling is potentially starting to look like an interesting option as well. For some countries, we look primarily at heating, but there are a lot of countries, and I'll talk about that a little bit at the end, where cooling has really started to be the main drive. If we look at Thailand, Malaysia, Seychelles, and Maldives, then it's really something where cooling is at the forefront of developing district energy in general. So this is a very interesting development as we start to look at cooling. To take a zoom in of how cooling is considered within this District Energy and Cities Initiative, the idea of it is very much that we can achieve different types of benefits and different types of improvements over other systems at the same time. So when we talk about district cooling, then the normal kind of basic benefit that we think about is the energy efficiency of it, and in many cases also the lower cost of cooling as we reduce the capacity needed. But increasingly, we're also starting to look more at the ways that the district cooling can contribute to the power sector and reduce grid stress and, in some cases, blackouts. But also, as Ines also mentioned, now that we've come forward with the Kigali agreements, much more about how we can use district cooling to reduce refrigerants. So these are the different benefits that we can work with as we start looking at what kind of role district energy can play, especially when we compare it to standalone systems. If we look at the work that was created within the District Energy in Cities publication, there are a lot of examples of the ways that district cooling has already contributed to these issues. There are some examples scattered around the circles here. But in many ways, it's a proven technology in the sense that we know very well what district cooling can contribute to these different benefits. So it's very much about trying to find out if these can apply and how these can apply within the different contexts at work. So to give a concrete example of one of the engagements that we've been in, a lot of the work that we've done with regards to cooling has been in India. And the first step in that, after we engaged with the Indian government and designated them really as a pilot country, was to start looking at the rapid assessments. India was extremely interested in order to be able to do this. So when we put out the application for cities, there were 5 that we started working with. You can see them on the map there. And the one that we've ended up engaging with as we move towards really the project development is Thane. So for the rapid assessment, the overall objective is to find out what the current objectives are, what the current policies are, and what the current strategies are in all the different cities. And in that sense, be able to make an institutional assessment of what is happening and what the potentials are, but also to look at a technical level at what the cooling demands are, what the current solutions are, and what the potentials for district cooling could be. So in terms of identifying high potential areas where it could be possible to put projects into place and where projects could be useful in order to be able to kickstart this development, is both to look at the catalysts on a policy element. Why can things change here? How are things changing? But also to implement some techno-economic tools to be able to make really kind of a quick, rapid assessment of what district cooling could bring in this area. So for each of these 5 cities, we looked at the different demands that they have, the different current systems that they have, and put those into what we call kind of the rapid assessment tool, which is really a quick calculation of what the options are. It's based on relatively little data inputs, and because of that, the uncertainty is fairly high. But at the same time, it gives a good indication of what the options could be. And the other thing that we've then done is really consulted with the cities, looked at what the local barriers are, looked at what the local potentials are, and based on that also made some recommendations to the different cities on how the next phase can be moved into and how we can start working with these. So in Thane, Zulum basically came to the phase where they'd identified both a greenfield and a brownfield project that could be worked with. When we're talking specifically about the greenfield project, the Hernandani estate was the one that had the most promise because it had a very mixed built-up area, so it had a very mixed use demand profile, but also because there was a very clear ownership structure and there was a very clear local governance structure, which was very keen to work with us and very keen to really explore the different options that were available and see how this could be done. So that makes it a very interesting test case, but also pilot project in order to see what kind of things are possible here and what the different barriers are that we run into. This kind of mixed use area, which is being built kind of on the outskirts of the city and done within these kind of township structures, is something which happens regularly. This is not something which is kind of an abnormality. So that also makes it very interesting to look at the replication potential of this. In India, we've had very strong support from the Ministry of Power in the form of ESL. And it's very interesting for them also to start looking at what the implications of this project are and how this can be either replicated or improved in other areas. So that was one of the main reasons that it became really interesting for not just the city itself, but also others to start looking at these areas. The basic outcome of the rapid assessments were here that it's probable that we can get a nice district cooling system off the ground. Again, because there's a fairly mixed use in the area, and also because the planning is relatively dense. So there's a relatively high internal rate of return in the sense that it's a good investment for a lot of people. There's a nice financing model set up by both the local authorities, but also the nationals and the partnerships that they're going into. And there are a lot of savings to be made by doing this, both in the sense monetarily, but also in the sense of energy efficiency and refrigerants. So based on this, the next step is to do this in much more detail and start looking at a pre-feasibility assessment. That also means starting to look at what the configuration of the district cooling system would really be, because that's not something where we've spent a lot of time analyzing in depth. So to look at what kind of combinations between chillers and what kind of combinations between any types of potential renewables could be. Then this is being done, I'll move to the next slide, but this is being done in coordination with the wider planning processes that are happening within the city, within the municipality. So one of the main advances that we've made in Thane really is that they've decided to set up a district cooling cell. That sounds a bit like they're opening up a prison, but it's basically a kind of coordination group within the municipality in order to be able to link the different planning processes that relate to cooling together. This is also being because, again, they're working towards both a greenfield and a brownfield project development. But it's a very efficient way for them to start convening stakeholders, convening the different legislation, but also just the different planning elements of the municipality in order to be able to make sure that they can include the things which are necessary. But also to collaborate at the national level. So with the Ministry of Power to be able to from the Ministry of Power, from EESL to be able to replicate these kind of things, but from the municipality's perspective also to ensure that they get the national support which they require. So while this is developing and while the pre-feasibility studies are moving forward for the pilot project, this also means that a citywide strategy is going to be created as part of this deep dive. And that becomes very interesting because then it moves really from the development of a project as a pilot or as a demonstration towards a citywide move towards efficiency and starting to see how it can be expanded in the future, how it can lead to an improved policy framework for the development of district cooling in the city, and then eventually towards the kind of full development of it overall. So this is a little bit the work that we've been doing in Thane, both on a small project scale, but also on the scale of contributing towards the planning processes that move forward. We have a lot of local partners there. We've worked a lot with the Carbon Trust, we've worked a lot with ICLE, and we've worked, again, a lot with the municipalities and with the national level. So this is really something where we can see the value of working with the local government, as they can really bring together all these different elements and apply the knowledge of non-local actors to the city and be able to use it in order to be able to develop the best solution for them. So just to give a short overview of what else we're going to be working on with cooling, we'll continue working in Thane. Again, these deep dives are currently being done, so there'll be the pre-feasibility studies and the citywide planning. Out of that, there will be a lot of capacity building that comes out of it to see what we can learn from this and how we can spread that as much as possible. We'll continue working to support the other cities in India, both with, again, the kind of project development, but also with the planning and the strategy development. ESL has worked towards having a national cooling action plan for the country, which is something that's not really technically within our remit, but is something that we'd very much like to support, because it's a really important part of being able to develop the national level support and framework for a lot of these projects to be able to go ahead, and for the rollout and the aggregation of projects like this. And then the biggest part of the work is going to be to start working with the other pilot and the replication countries. As I mentioned before, there's a lot of countries that we've been working with for cooling specifically, and a lot of that has come after the Kigali Agreement. So we're working on a KSIP project in Egypt, which has been confirmed and which we'll move on towards. In Morocco, we're working with the Italian government to start looking at the development of a project in Marrakesh, which is extremely interesting because it's a little bit different from the one that we've been working in Thane, in that it's not so much mixed use, but more specific use of hotels. And the kind of local setup that it has, basically a strip of hotels near the beach, is something which is very replicable when we look at other places and other areas where the cooling demand profiles and the potential for the kind of spatial aggregation are very similar. Interestingly, we're working with a few of island nations, both in terms of Seychelles and the Maldives, which are really interesting in that they kind of bring their own challenges. But there's a lot that we can learn from them and from the other cases that we've been working with there. And then in terms of direct replication, we've been doing a lot of work in Malaysia. There have been a few rapid assessments working through that. And in Thailand, we're doing more and more work. In Latin America, as I said, Chile was really the pilot country where we've been looking a lot towards the development of new district heating. But as you know, we're starting to look into the potentials more and more, and as the Chilean government is starting to look into the different ways that district energy could be used, cooling is something which is more and more on their radar. And we've recently started engaging with Colombia, where they have a few district cooling systems, to really see if we can both learn the lessons from that, but also bring it from an element of kind of project by project basis to something which is really aggregatable and can be accelerated. So that's the brief overview of what we'll continue to be doing, both within the District Energy and Cities Initiative, but also here in terms of the technical support at the Copenhagen Center on Energy Efficiency. There's some resources available here, both in terms of the knowledge management system, which is where we kind of keep a lot of the information and the lessons learned at the Copenhagen Center on Energy Efficiency, which is basically part of the website, and then also on the District Energy and Cities Initiative. So if there's anything you'd like to ask, then please feel free to put it into the box, and then we can address it in the discussion later on. And thank you very much for your interest.
Thank you very much, Susanna. It was a very interesting presentation indeed. We have one question, but as you said, we can leave it to the question and answer session and then come back to it a little bit later. I would like to present now our second speaker. Our second speaker is Burkhard Holz. He is an expert in district cooling, working for VIENNA Energy, which is one of the biggest utilities in Austria. And he will present us today district cooling from an operational point of view. Burkhard, the floor is yours.
So thank you for the invitation. Today I will talk about district cooling in Vienna. I'm from VIENNA Energy, which is an energy supplier, the biggest in Vienna, and we support customers with electricity, gas, district heating, district cooling, and telecommunication. So today's topic, district cooling. So why does an energy supplier have the motivation to support customers with district cooling? So the product cooling fits perfectly in our portfolio because we support our customers with gas, electricity, and so on, as I mentioned before. It offers us unique selling propositions, and it extends our value chain. For example, if we sell electricity or heating power, it's a business, but if you can like increase the level of your value chain, it's with cooling, it's even better. It offers us the opportunity of cross-selling. So in a lot of cases, our customers ask if we, for example, sell them heating, don't you have cooling as well? And it was still in former times a missing fragment to be the only actually full service energy supply in Vienna. And one point is, of course, we can use and still existing infrastructure like the fault clearing, the measurement, and the accounting. There are some benefits that we have, like here in especially in Austria. We have the possibility to use existing waste heat in summertime from the waste incineration for absorption chillers, and there are from the government subsidies for this use of absorption chillers. But I will manage it in my presentation afterwards. Absorption chillers, there are pros and cons, and it depends very much on the situation, actually very much on the price of the heating. Here is our heating sources, heating, not cooling, in how we support our customers. So I hope you can see like the point. So the dark gray area, it's actually, here is 1 year, and this is winter time and this is summertime. We're talking about heating right now. So this dark gray energy, it is made by waste incineration. So you can see waste incineration is, we have it all over the year. So even in summertime, there is still a waste incineration because we have only very small storage for waste. Green is energy from biomass. A light gray is energy from industry, and the red one is the energy from cogeneration. And only the yellow ones, it's like the heat from peak gas fired plants. So we are actually talking about summertime, which is almost this time, where we have waste heat from the waste incineration mainly all summer long. And this has to be used in any kind of waste. And we use this heat in absorption chillers to power our absorption chillers. And it's always a topic of prices. During summertime, we have this waste heat, which makes sense to use it. If you don't have waste heat, absorption chillers make hardly sense, in my opinion. So there is no must for absorption chillers, but if there is the energy during, there is energy, heating energy during summertime, it makes sense. And that's also one like Viennese point. We are right now doing research for a geothermal project with 120 megawatts of heating. So we will even increase this like band during during summertime. So we have much more heating energy for summertime. So that will decrease the heating price and make absorption chillers even more economic. So we're talking about absorption chillers, conventional chillers, just for the non-engineers. With a conventional chiller, you use electric energy to run a process to get cold energy, and you got the condenser, which is for the recooling. You have to recool it, and with absorption chiller, you use thermal energy instead of electrical energy. And you get also cold energy, and you have to recool this system. When we talk about district cooling in Vienna, we offer our customers two different ways of cooling. The one is the district cooling, As you might know it from district heating, there is a big plant, in that case a cooling plant, and via a district cooling network, we support our customers. But you know, the district cooling network is really small compared to the district heating network, at least in Vienna. And so we try to in topics of cherry picking, to get even big customers, and we call it like decentralized cooling. So we build up a small cooling plant, a chiller, at the customer side. We build up the recooling so we can support the customer with cooling. In both cases, the customer gets the same service. He gets cold power in his cold energy in his building. This is the district cooling within a whole, in the context of whole Vienna. And as you can see here, it's actually a district heating network which surrounds Vienna. And for example, this plant, this is a waste incineration plant, supports the district heating network, which surrounds Vienna. And we get a separate network, for example, here in Spittelau, which supports our customers with district cooling. It's not the same network as heating, it's a separate one, as you can see with these colors. For example, Spittelau, we do the recooling via the river water, which makes our machinery very efficient. I can show you data afterwards, how efficient our plants are. Or here, Schottenring, which is almost the same. We have a cooling network to support our customers. We have recooling with the river water, and the plant is connected to the district heating to support our absorption chillers with heating energy for cooling. But there are also some like decentralized projects, as I mentioned before. So we have a pretty lot of different ways to support customers. I will have then a short overview of every single project, and every project has a special thing. So here you can see how the increase of the connected power, we are around right here, around 140 megawatts of connected customers we've got right now. So some technical stuff. Spittelau, the plant which is here, I want to mention it in detail. We have two absorption chillers and one electrical chiller. The absorption chillers are powered by the waste incineration. We have there 140 degrees. Normally we have actually less temperatures, around 95 degrees, but in this special case we have 140 degrees. We produce cold water actually in the flow with 3.5 degrees. We support via a district cooling network to our customers. They have a heat exchanger there, and we support our customers. This is actually what we support our customers with, 6 degrees cold water. So here some, when we talk about district cooling networks, here is the network from Spittelau. Here's the cooling plant. It's also a waste incineration heating plant. So we support the general hospital and some office buildings. Here's something under construction. And we use, for example, plastic checked pipes with different diameters to support our customers. Yeah, we have the control of our district cooling plants works like this. I will just change to the original version. I hope you can see everything. So this is our machines right now with 3.8 megawatts of cooling power. The other machines are not running right, except the absorption chiller. So one electrical is running and one absorption chiller in this plant. We can switch to our customers. So for example, this customer right now needs 2.4 megawatts, and the second time 2.4, so 4.8 megawatts. This is our biggest customer, the general hospital, and you can see the temperature and everything. And for example, some charts, how the cooling demand was within the last days. So back to the slides. The cooling plant Spittelau. When we talk about energy efficiency, I made this slides, an energy review of 2014. Today it should be almost the same. It's just about the values of what is our loss in our networks, what is the efficiency of our machines. For example, in this case, in this year, we produced 55,000 megawatt hours of cooling power in the machines. The output, so we need the air conditioning of the plant itself and some losses within the cooling plant. So from the network, we got an output of the power plant of 54,000 megawatt hours. And to the customers, we delivered 50,000 megawatt hours. So that's actually a loss within the network and everything together around 10%. So you can, here is the loss again in the, it depending where you start from the 54,000 or the 55,000, depending how much the loss is. But that was what our customers were charged. So when you talk about energy efficiency, what is like the comparison? We have also there in Spittelau an air-cooled screw, which is almost a system a customer would install by themselves. They won't make a recooling via river water. That makes no economical sense. So the efficiency of the machine would be around 2 or 2.3, which is quite low. But our chillers, they make 6.4, depending if you calculate the pumps, 5.4. So we have almost doubled efficiency only in the electrical way, and there is no waste incineration included. The waste, you know, as I mentioned before, we use waste heat. Waste heat to run the absorption chiller, and this energy is almost for free because the waste heat is cheap, and it's also an ecological plus, of course, if you use waste heat with an absorption chiller to produce chilled water. So I want to have here a picture of a cooling substation. This is how a cooling substation looks like, and this is the hydraulic scheme of it. And this is one part of our contract. So we support customers. Here is the outside temperature. Here is the cooling temperature. Like for high outside temperatures, we support the customers with 7 degrees. In winter time, for low outside temperatures, we support them with higher cooling temperatures. That's because we want to use free cooling, because in wintertime, if the Danube Channel water or the river water is very cold, we can support the customers with like free cooling, and that makes the system even more efficient. So here are some other projects, and like every project has a little bit a special thing which I wanted to manage here. For example, Schottenring. Schottenring, we have here, like in the very center of Vienna, a cooling plant. We do the recooling via a river water, which looks like this. We have like mechanical filters. Here is a pump, and the water is pumped into the cooling plant. The cooling plant is built up like this, with absorption chillers, with electrical chillers, and with free cooling. So one of the questions might be why we use not just only absorption chillers. If we got waste heat, the absorption chillers, they are quite like slow in kind of topics of reaction. So it makes always a sense to combine it with electrical chillers. And also we use it in topics of economic, because we have, I showed it on on one of the first slides, we have this combination of a lot of cogeneration here in Austria. So if the electricity price is low, the heating price is high. and on the other side, if the electricity price is high, the heating price is low. So with this cooling plant, I have always one cheap technology and one expensive, and it might change within the year. And with these two technologies, I can do some hedging, and so we can always use the more economic part, either the electrical chillers or the absorption chillers. And here we support from this cooling plant our customers. Here is shown in yellow via this district cooling network. So we have an installed capacity here with 15 megawatts. Here are some pictures. This picture is, for example, from the water outtake at the river. There was to get the permission. There was this. We had it has to be that it's like almost invisible for the people. That's how it looks like this. Here is the pump. Here is a picture of the cooling plant itself. Here is another project. It's below the central railway station of Vienna, which is here. Here is our cooling plant. The recooling, we do it in here in this kind of park. It's done by open cooling towers. And we have a district cooling plant and support customers around this central railway station. It's actually our biggest cooling plant. And again, we have absorption chillers and electrical one to support our customers with cooling energy. Here are some pictures of the cooling towers, and you can see the size is really quite big, because here this is one of our employees. This project is in hospital, and we have like this interesting situation. Down below in the basement there are server rooms, and we use the waste heat of the server rooms to heat up the hospital in winter times. So it's our customers, they want us to combine heating and cooling, and that's what we see even more often. With this project, down below in the ground, there is a groundwater lake. It's not a floating groundwater; it's like a still standing groundwater, and we use this groundwater as a seasonal storage. So we can, during summertime, we can use this groundwater as for recooling, and we store the heating energy. And during winter time, we change the chillers to heat pumps, and we can use this stored heating energy to heat up the customer in winter time. And it's actually the biggest geothermal use in Vienna, with 2.6 megawatts of cooling and even more of heating. And we have like two different, a low and a high temperature cooling, a low and a high temperature heating, to support the customer really efficient with heating and cooling. This is one of our latest projects. It's called Austria Campus, where we have a cooling capacity of 11 megawatts and the heating of demand of 8 megawatts. Heating is done by district heating. Cooling is done by district cooling plant, which is installed right here. We have open cooling towers in the cooling plant, and I have a short webcam. So that's right now on the view. I'm sorry, the weather in Vienna is quite quite foggy. You can see here our cooling towers. Our cooling towers, three of them, and one of the two, there's the other one, hybrid coolers. And you can see all these buildings. They are our customers, which is quite one of the biggest projects of Vienna. Also, this part is heated and cooled by our plant. The really interesting thing is we have here also a combination of heating, cooling, and geothermal use. This picture we saw right now. So we got district cooling done by this cooling plant. We have district heating done by our heating plants. And in this case, like every single building we saw has a geothermal activated basement and geothermal activated drilled piles. So we have a heat pump, and we have the heating and the cooling substations, and the heat pump connects like the district heating, district cooling, geothermal, and the cooling and the heating of the customer. So we can, for example, if the customer has a heating demand, like right now, and a cooling demand for server rooms, like all of the years, we can do it with the heat pump to support them within this station. If there's some cooling missing, we deliver it by district cooling. If there's some heating missing, we support him with district heating. And we can always use the geothermal parts to store heating or cooling energy. So this is another project, just a really small one, but we wanted to try something. We wanted to try to support a customer with with cooling, and the customer has one really interesting demand. There was the demand not to have any recooling units at the rooftop, and so we tried to do the recooling via our district heating network. So we tried this first pilot project with a cooling demand of 200 kilowatts at 8 degrees. And we have a heating output with 400 kilowatts at 85 degrees. We don't need any recooling units. We do the recooling via district heating. So we have actually the combination of an electrical chiller and a heat pump. And we use the recooling from the chiller as a source for the heat pump, and then we support we use this way the recooling. We do it by our district heating network. The project it worked out, so we are going to have it like also in bigger dimensions than this pilot project was. Here are some pictures. This is the chiller plus heat pump combination. As you can see it here on the picture. There's some technical equipment. When we talk about cooling, there's always talks about prices. How much does the cooling, at least in Vienna, cost? We have actually 3 parts of a price in Vienna. We charge our customer a load price. This is 95,000 euros per megawatt and year. We charge them an energy price. This is 39 euros per megawatt hour, which makes at 1,000 full load hours around 35 euros per megawatt hour. It depends very much on the project and the customers. They were charged when we start the constructions with an invest charge of around 30%, I would say, yeah. And the service limit is always the substation. And of course, if it's like a very big customer, there will be like a better price than, like, for example, the 95,000. There will be like 85 or something, like 10 to 20% discount. So, what are the key factors for district cooling? At least what do we see as key factors in Austria, in Vienna, for district cooling? District cooling makes sense in an area where there's some there's a high concentration of cooling, so there are big customers close to each other. Because what we see in Austria, the network costs are quite high. So we're talking about 1,200 to 2,500 euros per meter, which makes a project very fast not economic. For us, our customers with an all over the year demand, like hospitals, like office building, like server rooms, like industry, are much better than other customers. So right now we have actually no private households connected, just industry, offices, and hospitals. Of course, it's better if the spread of cooling are at high temperatures, the spread of in between return and flow. The most challenging topic for district cooling is always the recooling. If there is the possibility for river water cooling, it's perfect. If not, you have to think about open cooling towers, whatever. If there are some energy sources like rejected heat, it makes sense to build up absorption chillers. If you have to pay like a lot for the heating energy, it makes no sense to run any absorption chillers. And of course, you need some place. If you connect to district heating, the absorption chillers, for example, you need some place at the customers, in the streets, wherever, to build up a cooling plant. So, conclusion. In Austria, we managed to have district cooling as an economic business model. Susanna managed before. There was a project with an ERR of 70%. Well, there might some projects some customers where we can manage such a high ERR, but normally it's much lower. It's, I would say, around, we make projects around 6 to 7, 8, 9%. Though, anyway, it's an economic business model. If you got rejected heat, absorption chillers are a perfect add-on. There's no must for absorption chillers, but if you have the possibility for rejected heat, it's perfect. Yeah, customers are very interested in district cooling. We in times of raising temperatures, like a lot of customers consider at least some air conditioning or things like that. We have actually in Austria at least in high relation of projects. The planning effort is quite high, so we have a small team to build up this project and to plan all this stuff. And what we see is like in headlining time around more than 1 year to get the project, to get customers and everything. And projects require quite high investments. So we're talking about, in Austria, at least in between, I would say, 400 to 1,000 euros per kilowatt. And we've got within our organization a small team which builds up just this cooling plants. So I've got actually a few employees, and we build up this cooling plants. So that was it from my part. Thank you, and yeah, greetings from Vienna.
Thank you very much. We are running a bit out of time, but we have some questions. So maybe if you agree, we can perhaps just have 10 minutes more to reply very briefly to some of the questions.
For me, it's okay.
And then, yeah, and then those that we cannot answer because of this time limitation, I would send them to you over email, so you can continue later on with the discussion. So one of the questions is from Alexander Sharabarov, and his question is, do you a pricing pressure from renewable electricity, wind, solar, etc., on electricity from CHPs, especially in the summer? How do you deal with it?
I didn't get the question. If we use for the electrical chiller, if we use like energy sources that are renewable.
Yes.
Yeah.
I understand.
Yeah. Okay. It depends very much on our customers' need, demand, wish. For example, the first project I showed you, SPITTELAU, we are right in the basement of the waste incineration. So there we have actually the electricity, 100% of a steam turbine of the waste incineration plant, 100% renewable. With other projects, it's different. We always say to our customers, if you want to have it like also the electricity, not only the heating, the rejected heat, renewable, but also the electricity, we can offer and like buy just renewable electricity. So we offer it to our customers in case the customers want it.
Thank you. We will take 2 questions more. The next question is from Tiga Asta. He says, in the UAE, district cooling has been costing the operators due to the low delta T syndrome. This is basically because the district cooling center have higher capacity than what is required. So much oversizing defeats the purpose and doesn't help EE. How do you prevent this from happening in developing countries where the need for cooling is absolutely essential, but the HVAC designers are not responsible for EE?
Well, I guess I didn't get the question.
It's more for Susanna, I believe.
It might be a topic we never have been facing.
Susanna, do you think? Yeah.
I think it's a question that has a point in it, but I'll try to answer it. I mean, it's something that we talk about a lot. I mean, it's also when we go to areas where district cooling does not exist. For example, in India, we've been talking with hospitals, we've been talking with malls and these kind of areas. They're used to having a certain capacity because that is the capacity of chillers that they have. So it's a switch to be made, and I think it's a very important point that is made in that if you completely overcapacitate these systems, then you lose a lot of the benefits, particularly in terms of cost. And you know, no one wants that. No one's intention is to go ahead and do that. But at the same time, particularly for hospitals and these kind of things, there have to be some safety guards. The hospital that we're working with in India has the issue of wanting to refrigerate a lot of medicines, and that's not something where you can take large risks. You know, there has to be a very high kind of factor to ensure that the cold that is required can be provided there. So it's an issue that we know about. We've been trying to do some benchmarking and trying to kind of figure out how we can provide some better data and provide some better knowledge on this, because I think that's one of the difficult things when we talk about cooling, is that it's not as well established as a market as something like heating. So there's no kind of benchmark data that we can use to provide things and to show things. But you know, if there were an easy answer, then I'd love to give it to you, but it's just something that we have to be very aware of in an ongoing conversation that needs to happen.
Am I right? Are we talking about overcapacities, or?
Yeah, pretty much.
Like one thing I can at least at least I know that this thing about our customers. If we got a customer that says, okay, he needs 1 megawatt of cooling power, we see that like normally they only need maximum 0.6 or 0.7. In times of economic business models, that means you can support with 10 megawatt of cooling plant, you can support easily 14, 15, 16, 17 megawatt of connect 15 megawatts of customers. So that makes your business model actually more economic.
Thank you both. And just the last question, and then the rest of the questions I will send them to you via email, so you can engage on a conversation. Thank you for the interesting presentations. This is a question from Corrado Shannon. Liquid natural gas is more and more considered as clean fuel. They're in transition towards renewable energy sources from marine propulsion too. How do you see the integration of LNG regasification, generating cold, with district cooling? And do you know any examples of these applications?
I only can say we in Austria we use for absorption chillers, there are like different forms to build it up. There has to be a heat source. It doesn't matter if it's like heat from district heating, heat from a gas burner, from oil burners or electrical one. This absorption chiller just needs heat from any source. So if the price for LPG is cheap enough to run an absorption chiller, that's an economic business model. I don't know if it's ecological as well, because I would say it's more ecological if you use the gas in a first step in a steam turbine to produce electricity out of it, and the waste heat which is produced by the steam turbine, the very low temperature heat, you can use this rejected heat for the absorption chiller. That would make sense in my opinion. So you can use the gas like 100% of the energy, or almost 100.
Thank you. We have also one of the sorry, Susanna, just a quick thing. We have also one of the attendees, Alex Ivancic. He says that there is also an ongoing project for the use of waste coolness from LNG regassing in Barcelona, in Spain.
Okay.
Please,
yeah, I think that I was just going to add that. Well, I can add that I think it shouldn't be using gas directly, but if you're processing it, and I think it's very much a pressure. I don't know very much about the technical details of it, but I think it's very much about putting it under pressure, and that creates heat. Then that's a good idea to use it. One of the prerequisites that you need for that is then for it to be near an area where you have the infrastructure in place. I don't think that this is the type of thing where, if you have a processing plant for LNG, but I can also imagine as we move towards other types of gas, then for fuel production, to then build a heating system on it. I think it's very much as Burkhardt says, that if you need to have a district cooling system and then use that excess heat and therefore have that excess heat within the vicinity of your district cooling system. So it's also a spatial game when it comes to these kind of things, because if you have them out in a harbor in the middle of nowhere, then it doesn't do very much. Whereas if you can put them close enough to an area where it can be recovered, then it can become a good idea. But if it's not near a district cooling system, then it's never going to be possible. So that's just a kind of side note to it.
Thank you very much, Susanna. We still have more questions, but I'm afraid the time is running. But I will make sure to put you in contact, so you can continue with the discussion. And just very briefly, I just would like to ask you both if you can very shortly tell us about your conclusions or what the attendees should take home with them.
Yeah, I can start.
I can start. Okay, it's always difficult to start. Well, I would say, first of all, district cooling is an economic business model because always in the demands is if there is something ecological, it's not economical. That's not true. It's true with it's not true for district cooling. District cooling is an economic business model. So if there is a problem of financing, I think if you got the customers or some like big customers, you can always make a economical and then of course an ecological project there, and that should be work all around the world.
Thank you, Susanna. I agree. No, I think it's a very easy message from here on. No, I think, when we talk about district cooling outside of Europe, it becomes extremely interesting because we know that Europe is only 5% of the district cooling market. I think it's a very interesting time for district cooling globally, especially with Kigali Agreement and a lot of countries really starting to look at what the effects of cooling are on their grid and what they need to do about it. That also means that it's a very important time to continue spreading the knowledge and spreading the information that exists within the sector about the efficiency of district cooling systems, and especially this link to being able to use waste heat and being able to contribute to the power sector. But at the same time, working on a local level, there's a lot of planning processes, and there's a lot of institutional work, and there's a lot of kind of very technical nitty-gritty things that need to happen to be able to ensure that the best solution is found. So it's both kind of a high-level message on energy efficiency and a much smaller scale development of really projects and known things and best practices in terms of implementing them that we need to be working towards.
Well, thank you very much for your presentations and well for the overall contribution. And just to wrap up this webinar, also thank you to all the attendees for taking the time to be with us today. Thank you and have a nice day.
Thank you.
Thank you. Bye.